Hello, my name is Cade and this is my TED Talk. I'm here to talk about space and time, two completely different topics, which together make up space-time. Now, what is space-time? It refers to whatever external reality underlies our collective experiences of the space between things and the time between events. Now, why can't space and time be the same concept? Why add another curveball? Well, because imagine this. There are two observers, observer number 1 and observer number 2, that move relative to each other. They don't agree on the time between events, the space between things, or the order in which these events happen, but both measured these events correctly, meaning both are true. Well, what does this mean for implications? Let's talk about it in terms of the sequence of events. For observer number 1, A is the past, B is the present, and C is the future. And observer number 2, C is the past, B is the present, and A is the future. That means my past is your future. Well, how is this possible? Both are measured properly, which means that there's no concrete division between events that occur. So what does this statement mean? Does that mean that everything is subjective? Well, the answer is maybe. But how do I explain that? Causality. Now, where to start? The best starting place for causality is universal agreement. But what exactly is causality agreeing on? It's called the SI equation. The change in x squared minus c times the change in t squared, where each represents the time between events, the speed of light, and the time between events. Now, the space-time interval. It's where two observers have a different time and a different space between events, but they still agree on this one equation. Well, what does this SI interval tell us? Well, since the equation involves subtraction, that means the SI, or space-time interval, can either be negative, positive, or 0. If the interval is positive, A cannot influence B, and people always disagree. Now, if it's negative or 0, A can influence B, and vice versa, and everyone agrees all the time. That means the SI interval tells you whether A can influence B, which means they can disagree on the order between events, the time between things, and the space between things, but they all agree on causality. So what does that have to do with space-time? Well, everything, it turns out. A man named Hermann Minkowski noticed that the SI interval equation looked a lot like a distance formula in a non-Euclidean space. This equation gave birth to the idea that reality does not evolve through space and time like a three-dimensional shape, but instead, it's in a non-Euclidean space. It's 4D, and it's just there. There is no evolution, and there is no time. This 4-dimensional space is called space-time, and all events ever in history are just points in this 4D space, and only points that have geometric relations between each other are considered real. Now wait, so I can blow your mind. That means if I am the sequence of all events in my lifetime, and I am an object in space, a line segment really, from birth to death, do I move along this line segment? No, I am the line segment, and there's no motion, which means that not only is my future predetermined, it already exists.